Okay, we in your textbook we talked, or you can read in the same chapter about three more probability distribution. We have the student t distribution, we have the chi-squared, and we have the f distribution. Now I'm not going to cover this one and that one. Okay, so we're just going to cover one more, which is the t distribution. Why? Because we're going to use that a lot in further chapters. Okay, so you are not responsible for the chi-square, neither for the f distribution. Okay, the t distribution is also widely used, not as much as the z or the z distribution is used, but it is also widely used. The t distribution has a parameter called the degrees of freedom. Also, I'm not going to really discuss a lot about that. All what you have to do is to know that this is the parameter of your distribution, and I'm going to show you that when we come to read the t table. Okay, and the mean of the distribution is also zero, like the z distribution, and it has a variance that's equal to nu, which is the degrees of freedom. It's denoted by nu, which is the Greek letter for n. Okay, so it's a nu over a nu minus 2. So obviously these apply for a nu greater than 2, otherwise the denominator will be negative, and the variance cannot be negative. Now, how does the PDF of the t distribution look like? It's very similar to the normal distribution. Both are symmetrical with respect to the mean, which is 0. Okay. However, the difference between the PDF of z and PDF of t is that the curve for t, we call it a mound shape. Okay, it's not bell shape. Mound shape here. Why this? Look at the tails. Remember, in the bell shaped, I told you that in the tails of the curve becomes very asymptotic with respect to the horizontal axis. While here, no, it's not like that. We call that a fatter tail. Okay, this is just an observation for you to note. Something important about the t curve that you need to know is that as the degrees of freedom nu increases, the curve becomes more and more similar to the z curve. Okay, so look at these. Here I showed you 3t distribution curve, where the blue one correspond to a very, very low degrees of freedom, 2. Okay, so you can see that it has a very, very heavy or fat tail, while the second one, the orange one, has a higher degrees of freedom of 10. Nu is 10, so you can see that the tail gets much less closer to the horizontal axis, so it becomes more asymptotic. And the third one refers to a nu equal 30. It's even more. And as you go further, it becomes more and more looking like a bell shape. In fact, in the t table, you can see that when the degree of freedom becomes as high as 1000, the values of t becomes equal to the values of z, because then you'll be looking at it as a z curve. All right, so in order to find the t values, you know that, as I mentioned before, that t distribution has a parameter which is the degrees of freedom nu. So also, because it's possible to have so many values of nu, it would not be practical at all to prepare different table for each nu. Instead, we use one unique table, where different rows refer to the different possible values of the degrees of freedom. But what's important for you now to know that the areas, and I'm going to discuss that later when I showed you how to read the t table, the area is referred to the area on the right hand side of T. Okay, so now you see also why I was insisting that you understand the notation ZA when we were considering the Z table, right? So TA is the value of T such that the area on the right hand side, you see this area on the right hand side is equal to a certain A. And now for the same A, we can find different values of T depending of what is in U. That's why when I want to ask you to find a specific value of T, I have to tell you what's the area and what's the degrees of freedom. All right, now in some cases you want to find the T values corresponding to a degree of freedom, but you cannot find this degree of freedom in the table. So what do? You locate the closest degrees of freedom that is found in the table and use that T value. It's not going to be the accurate one, but it will be close enough for you to answer the probability question. So how do we read the T table? Here I'm showing you only the upper part of the T table that I'm going to make it available for you on Blackboard. Like the Z table, we have a nice legend that will give you an indication what are we reading. So you can see that the areas that you will see in the table, and I'm going to come to that, are the area on the right hand side, and this will be the T that you will read in the table. Okay, now what do we see in the table? It's exactly it's not exactly, but it's opposite, unlike the Z table where the content of the table represented the area. No, here it's different. These are the T values, and the areas are the values that we can see in this first row. And the first column shows us the different degrees of freedom. Okay, so this is what we see in a T table. Now let me clean it up so that I can do some examples showing you how to find the values that we are looking for. Okay, so for example, if we want to find the T value corresponding to an area of 0.05 and degrees of freedom of 10. Remember, what's 0.05? This is the area on the right-hand side. So it is this area, right-hand side. And these are the areas that I told you we will read in the first row. 0.05, that means I will look into this column, right, corresponding to 0.05. Now, the degrees of freedom is 10. So I go and locate in the degrees of freedom, I locate the one which is 10. So it's that row. So now I go here and I go in this column, and the value in the intersection of this row and column, this will be the area. This will be the T. So how do I express now the three parameters? I can say that for a nu of 10, the probability that T is greater than 1.812, right? This is the value that we just read from the table, is equal to 5%. Okay, so now here, this is how I showed you the three elements that we use to find the T. Another example, find T 0.025 and a degree of freedom of 32. Okay, what does it mean? So that means the area on the right hand side of T is 0.025. So I go to the first row and I locate 0.025. However, here I have a degree of freedom on up to 10, so I need to show you one more. I go down and I want to look for 32. Unfortunately, because I have to give you a very concise table, I cannot give you a table where we have thousands of degrees of freedom. So I have 30 and I have 40. So as I mentioned before, go for the one that's closest to the one that you're looking for. And we're looking for a degree of freedom of 32. So we look into the row corresponding to a degree of freedom of 30, and here we go. It's under the column corresponding to the area of 0.025 that we are interested in, and this will be our t-value. Okay, so I hope that that was clear for you. Final notes about the t-table. In the previous slide, I showed you part of the t-table, and you could see that all the t's are positive. All right, but a t value can be also negative, because remember, it's a distribution that has a mean of 0, and it's symmetrical, which means we have as many values that are negative as we have values that are positive. But how can we then find a negative t value? We will use the symmetry of the t curve. Okay, so what we can say is that a t-value that has an area on its right equal to a, okay, then I can find a t-value that has an area on its left also equal to a, and this will be equal to minus that t. Okay, so for example, if we know that that 1.812 is the t-value such that the area on the right-hand side is 5%. That means, okay, let me show you this here quickly. It's very bad, but bear with me. Okay, if this is 1.812, this is a t-value such that this area here is 5%. Okay, which means what? Which means there is a symmetrical one, so a minus 1.812, such that the area on the left-hand side will be also equal to 5%, right? The symmetry characteristic, it's a very important one. A final note that in the z-table that I'm going to provide you, if you look at the last row, you will recognize, or you realize, that the t-values are nothing but the values of z that you can see in the z-table. Okay, why is that? Because, as I told you, as the degrees of freedom increases, the t distribution becomes more and more similar to the z distribution. Okay, so that's it. This will end our topic. Hopefully everything was clear for you. I encourage you to do practice, practice, and practice. Thank you.